Okay, this is from Mrs. Cucci's College Now Pre-Calculus class. We're on lesson 1.6 and we're dealing with solving linear inequalities. By the end of this lesson, you will be able to solve linear inequalities, solve compound inequalities, and solve applied problems using inequalities. So today is all about inequalities. All right, so an inequality is a sentence with one of these signs, less than, greater than, less than or equal to, greater than, equal to. And it's used as the sentence's verb, okay? To solve an inequality is to find all of the values of the variable that make the inequality true. Each of these values is a solution of the inequality, and the set of all of the solutions put together is called its solution set. Inequalities that have the same solution sets are called equivalent inequalities. So we've got some principles for solving inequalities. For any real numbers, a, b, and c, we have the addition principle for inequalities. And what that is if a is less than b is true, then a plus c is less than b plus c is also true. And we saw this when we were dealing with equations too. It's just now in terms of inequalities. Multiplication principle for inequalities. If a is less than b and c is greater than 0 are true, then a times c is less than b times c is true as well. And if a is less than b and c is less than 0 are true, then a times c is greater than b times c is true. And all of these statements hold true when we're using less than or equal to as well. Okay, so let's solve the first one, and then we're going to graph our solution. So here's our first inequality. 3x minus 5 is less than 6 minus 2x. So our goal is to isolate our variable. We want to get the x alone. So the first thing we need to do is isolate it to one side of the inequality. So first step is we're going to bring this 2x over by adding it to the other side. Okay? So we get 5x minus 5 is less than 6. Okay, so we still haven't isolated, so the next step is to get rid of that negative 5 by adding 5x is less than 11. And then we divide. X is less than 11/5. Now, the last step of this says graph the solution set. So what we're going to do is we're going to graph that on a number line. Okay? I'm going to put it up here. And 11/5 is 2.5. So we have to keep that in mind. We've got 0, 1, 2, 3, 4. Okay? And you do want to have other values as well. So keep that in mind when you're drawing these things out. You should include all of those values. Less than. Well, we've learned two different ways to do this. You can use an open circle or you can use open parenthesis. Okay? It's up to you which way you do it. You're going to see them done both ways. For the sake of doing something different, let's use this one here, okay, the parenthesis. All right, 11/5. X is less than 11/5. So at 2.5, you're going to open that parenthesis, and I guess I'm a little bit off. I apologize. And then we're going to shade everywhere that it's less than, so we're going to be going this way. Okay? Okay? Again, I'm sorry, I know my pen went a little beyond where it should have gone. I apologize for that. It should be at 2.5. All right, so let's try another one. Solve the inequality, then graph the solution set. Okay, so first step is to get all those x's to one side. So generally speaking, you don't want to have to deal with a negative value of x or a negative coefficient of x, so we'd like to keep it positive. So what I'm going to do is I'm going to add over the 7x. So we get 13 is greater than or equal to 17x minus 4. Next step is to add that 4 over. We get 17 is greater than or equal to 17x. And then divide by 17. 1 is greater than or equal to x. Now, if you generally like to write it with the variable first, you can. But please make sure that when you rewrite it, you orient the inequality sign appropriately to what it was. This says x is less than or equal to 1, so make sure that it continues to say x is less than or equal to 1. All right, so now let's deal with the number line. And since it's less than or equal to, we use a square bracket or a closed circle. And again, you will see them written both ways. Less than or equal to 1. So at 1, you're going to have that square bracket, and then you're going to shade everywhere where we have values that are less than 1. Okay? All right, so let's move on to something a little bit different. And this is something that we're going to be dealing a lot with this year. We're going to be talking about domain in depth because we start dealing with things like piecewise functions and higher order polynomials. So it's really important that you guys understand domain. Now I know that you guys know domain means my x values, right? My independent variable. But you also need to know how to find the domain when we're dealing with functions that are kind of funky looking, right? We have the square root of x minus 6 here. Now, we have to think about what happens with our square root functions, what we can have happen and what we cannot have happen. Now, you can have the square root of 0. That's totally possible. The square root of 0 is 0. What we can't have is the square root of a negative value, okay? So the way that we go about finding domain for these radicals, these square root functions, is we write an inequality, okay? The radicand, the expression underneath the radical, can be anything as long as the quantity winds up being greater than or equal to 0. So there's our inequality. You take your radicand, and you set it greater than or equal to 0. I want the domain. I want to know all of the values that are going to make this expression greater than or equal to 0. So we add over that 6. We get x is greater than or equal to 6. So any value from 6 and up is going to be part of our domain. Okay? So, having said that, this is all going to be part of my domain, right? Wait for that to go away. That's all going to be part of my domain. I want to know what's not going to be part of my domain. If 6 can be, anything less than 6 can't be. Okay? So any value that's less than 6 can't be, or isn't part of my domain. And if you think about it, this one has that equal to 6, so this one can't have my equal to 6. They can't both be equal to 6 there, okay? So my domain is all real numbers, that's your double backed R, such that x is greater than or equal to 6. Okay, my domain is all real numbers such that x is greater than or equal to 6. Okay, any value that's less than 6, 5.9 repeating, is not part of my domain. That's going to give us an imaginary value. So that's how we find domain for radicals. Okay, you take your radicand and you set it greater than or equal to 0. That's if we're dealing with a basic radical, a basic square root function, okay? That does not work when we're dealing with fractions. We're going to talk about that a little bit after. Okay, let's try the next one. All right, so now this one's a little different, right? I have that square root function. You're telling me right now in your head, you're saying, okay, I know that it has to be greater than 0. But now we have two issues here. Not only do I have the square root, but I also have a fraction, okay? What do we know about fractions? What can't I have in the denominator? Well, I can't have 0 in the denominator. So if I have the square root of 0, now my function is undefined. So my radical has to be greater than 0 instead of greater than or equal to 0. The reason being, you can't have 0 in the denominator of a fraction. All right, so what we do is we take that radicand and we set it greater than 0. Easy way to solve for x for this would be add over the x. So you get 3 is greater than x, or x is less than 3. Okay, so my domain is all real numbers such that x is less than 3. Okay, so when we're dealing with these types of functions, we're talking less about what's not in our domain and more about what is in our domain when we're dealing with inequalities. Okay? And again, we're going to be doing a lot of domain, so these are very important that you understand. Pardon me. Okay, so compound inequalities. When two inequalities are joined by the word and or the word or, a compound inequality is formed. A compound inequality like -3 is less than 2x plus 5 and 2x plus 5 is less than or equal to 7 is called conjunction because it uses and. The sentence -3 is less than 2x plus 5 is less than or equal to 7 is an abbreviation for the preceding conjunction. Okay, so when you have the term and this piece right here is the same, you can set up a conjunction, okay, an abbreviated conjunction. All right. So let's solve this one and then graph the solution set. And you've done these before. This isn't new for you. All right. So first thing we need to do is we need to get that x alone that's in the middle of my conjunction here. So I want to move the 5 away from it. Now when we move the 5 away from it, we have to remember to move it away using its inverse operation, which is subtraction, but you have to take it from each side of the inequality, okay? And then when you divide, same thing. You have to make sure you take it from each side of the inequality. Okay, so there's our solution set. Now, the graph of this is going to be a little bit different because we're actually dealing with two inequalities here that we've kind of brought into one. Okay. Now, this is saying x has got to be greater than 4. If you're just looking at this piece here, right? X is greater than 4, and x is less than or equal to -1, or positive 1. So at 1, I'm going to have that square bracket, and at -4, I'm going to have the open, and then it's everything shaded in between. Okay. So x is greater than -4, so shading this way, right? And x is less than 1, so shading this way, and it meets in the middle. Okay, next page. Compound inequality like 2x minus 5 is less than or equal to -7, or 2x minus 5 is greater than 1 is called a disjunction because it contains the word or. So conjunction and disjunction or. So with this one, you actually do have to solve it as two separate. You can't combine it into one like you can with a conjunction. So they do have to be solved separately, which isn't a problem. So you just go ahead and solve as you normally would. Add 5. We get 2x is less than or equal to -2 on this side, and 2x is greater than 6 on this side. Then we divide by 2. And we get these two inequalities. Okay? Now we're going to graph these. Okay, so x is less than or equal to -1. So less than, meaning it's going to go to the left. So -1, you're going to have your square bracket, and it's going to go to the left. Okay? X is greater than 3, so open bracket, and then to the right. So there is my disjunction. Notice the disjunction does not meet. They go in opposite directions where the conjunction meets in the center. Okay, so let's look at an application. Let's talk about income plans. Income plans for her house painting job. Erica can be, that should be said, paid, not paid, paid one of two ways. Plan A is $250 plus $10 per hour, or Plan B is a straight $20 per hour. Suppose that a job takes n hours. For what value of n is Plan B better for Erica? Okay, so we have to think about what we have here. Suppose that a job takes her 20 hours. Okay, 20 hours. Then n would be 20 for the number of hours it takes her. And under Plan A, right, under Plan A, Erica would earn $250 plus $10 per hour times 20 hours. Okay, so for that one, she would earn, let's see here, this is $450. Okay, now if she was working Plan B and she worked 20 hours, she'd have to take the 20 hours times the $20 per hour, and she'd be making $400. So for Plan A would work out better for her. She'd make an extra 50 bucks. Okay, so we know kind of how to work it. So what we need to do next is figure out an inequality. So here's how we plan this out. What we're going to do is we're going to say, okay, if I had the income from Plan B, right? So here's Plan B. My income from Plan B would be 20 times the number of hours that I worked. We want that to be greater than, if I want it to work better, right, I want to make more money, the income from Plan A. So $250 plus 10 times n. Okay? I want to know for what values is Plan B, for how many hours is Plan B better than Plan A. So we set up this inequality. So now we're going to solve it out. So subtract over the 10n. We get 10n is greater than 250. Divide by 10, and we get n is greater than 25. Okay, so anything more than 25 hours is going to be better to use Plan B. Okay, so anytime she's working more than 25 hours, she wants to make sure that she tells them it's going to be $20 per hour instead of $250 plus 10 an hour. Okay, so that's it. All right, now make sure that you come in prepared with any questions tomorrow, and I will see you then. Thanks, guys.